but it's important for us to have the foundations of trig. Now the beginnings of it we're going to start with is Pythagoras' theorem, which if you remember from geometry in high school is just a squared plus b squared is equal to c squared. Now the c squared is your hypotenuse side, which is going to be your longest side. And generally what we're trying to do is figure out what the size of a side is, not the square of the size of a side. So what I want to do is I want to get rid of this square. In order to do that, I have to square root the c squared and to get the square out. Once I do something to one side of the formula, I got to do it to the other side. So it ends up being c is equal to the square root of a squared plus b squared. Let's see how that looks in a formula. See what I mean here? I've got c is equal to the square root of a squared plus b squared. Now let's throw this at a triangle and see practically how this will play out, trying to determine the sizes of the sides, whether they be a and b or the hypotenuse c. Now here I've got us a right triangle. We know it's a right triangle because I've got this square box here that tells me that that's 90 degrees, which also tells me that these other two angles have to add up to 90 degrees because we know that all three angles in a triangle have to equal 180 degrees. We also have A side and B side here, which will be given proper names in our next video, but right now we'll just call them A and B. And the important side here is this C side. That is our longest side, aka the hypotenuse. The hypotenuse will always be the longest side of a right triangle, so if you calculate something and it works out to be smaller than A or B, you've done something wrong. And we also know that because it is opposite the 90-degree angle, so it will always be the longest side. So let's throw some values at this. A and B have given the values of 4 and 5. We're trying to determine what C is here. Now using Pythagoras' theorem, we know that a squared plus b squared is equal to c squared. So we know that the formula is going to be 4 squared plus 5 squared is equal to c squared. So now that we've determined that c squared is equal to 4 squared plus 5 squared, let's get rid of these 4 squareds and 5 squareds. We know that 4 squared, which is 4 times 4, is equal to 16, plus 5 times 5, which is equal to 25. C squared is equal to 16 plus 25. Now that I've determined that c squared is equal to 16 plus 25, why don't we just add 16 and 25 together and be done with it? So c squared is equal to 41. Now that I've determined that c squared is equal to 41, I'm not looking for c squared, I'm looking for c. So we need to get rid of this square somehow. And like I said before, we have to square root this side to get rid of the square. And whatever we do to this side, we have to do to this side. So c is equal to the square root of 41. So go ahead and punch that in your calculator. C is equal to the square root of 41, and you're going to work out that c is equal to 6.4. So congratulations, you've just solved for the hypotenuse, which is this c, and so let's get rid of c and throw the answer in there. So there we go. Now we've determined that 4 squared plus 5 squared is equal to 6.4 squared. Now what do we do though if we have a hypotenuse side in one of these sides and need to determine this side? As we did before, let's throw some numbers at it. I've got the hypotenuse is 450 and the B side or the A side is 225, sorry, the A side, and now we want to determine what the B is. So what we're going to do is let's plug into the formula what we know. We know that the formula is a squared plus b squared equals c squared, or c squared is equal to a squared plus b squared. So let's throw that in there. We know that 450 squared is equal to 225 squared plus b squared. Let's throw that into our formula. Okay, so we got that. 225 squared plus b squared is equal to 450 squared. Now we need to get b alone. So what we have to do is we have to subtract this 225 squared out of there. Now even before we do that, let's get rid of these squares. Let's figure out what 225 squared is and what 450 squared is and deal with those numbers first. So we see that 225 squared actually works out to be 50,625, that's a big number, plus b squared is equal to 202,500. Now we need to get b alone because we need to figure out what the b is, right? We're trying to figure that out. We can get rid of this 50,625 by subtracting it out of this side. See this plus here? That means that we have to subtract this to get rid of it. As with any equation, whatever you do to one side of the equation, you have to do to the other. So b squared is going to equal 202,500 minus 50,625. So all we've done is we've moved the equation around here. So we have b squared is equal to 202,500 minus 50,625, which works out to be 151,875. So we're getting closer to our answer. B squared is equal to 151,875. As before, we need to get rid of the square. That doesn't do us any good. Let's square root the b squared, and then let's square root 151,875 and get our answer, because it's going to be b is equal to the square root of 151,875. So we're starting to see the answer get closer and closer here. B is equal to the square root of 151,875. Punch that into your calculator, and we get our answer of 389.7. So we have determined that 450 squared minus 225 squared gives us 389.7 squared. That is determined the size of B. And that basically completes our walkthrough of Pythagoras' theorem. It doesn't matter if you have this side and this side, you can go a squared plus b squared is equal to c squared, or if you have this side, you're just going c squared minus this side is equal to this squared, or c squared minus this squared is equal to this squared. It's not too shabby at all. It's not too hard to walk through. This should just be a review from grade 12, or not even grade 12, probably grade 10 geometry. In our next video, we're going to start getting into some more trig functions, talking about the ratios of sides and starting getting into sine, cosine, and tangent. In this video, we're start getting into trig functions, sine, cosine, and tangent. But before we do that, what we have to do is name the sides of the triangle. We have this side here, which we discussed in the last one, is always going to be called the hypotenuse. But this fella and this fella, they have different names. Now it's all going to be based off what we call our designate angle. Now you see this little funky Greek symbol here? We call that theta. And in this case, this is my designate angle. So let's walk through how I name these sides based off the fact that this here is my designate angle. We know that this is the hypotenuse. There we go. Now we have our designate angle sitting here, and we have our side over here, which is sitting opposite of that. Guess what that side is called? Yep, that's right. That's our opposite side. Now we also have this side that's sitting down here that is sitting adjacent to the theta symbol, or the designate angle, and you notice I said adjacent, so guess what that name is going to be? Yep, you guessed it, adjacent. Now that's all based on the fact that this theta, or this designate angle, is sitting here. Now what if we moved it up to this side here? Would that change things? 100% yes. Now the hypotenuse is always going to be the hypotenuse because it's the longest side, so that didn't change. But this side and this side are going to change names. Let's move that theta up to here. Our designate angle is now up top, which means that this stays the hypotenuse. Now here comes the changes. Now this side, which used to be the adjacent, is now the side that is opposite our theta, or our designate angle. And this side over here, which once sat opposite our designate angle, is now sitting adjacent to our designate angle. Now when we start dealing with these things, we're going to talk about the ratios of the sides of the triangle and how they're related to our designate angle. They all have ratios. Each side here has a ratio which will help us determine what this angle is. So let's flip this triangle back onto its side here and make this our designate angle and talk about these ratios. Now on this side, I've got my designate angle. This will be my opposite. This is my hypotenuse, and this is my adjacent. If I want to figure out what this angle is, somebody who's smarter than all of us has determined that the sine of this angle is equal to the ratio of my opposite side over my hypotenuse. Now that's not where it ends. There's others. We also could say that the cos of this angle, or the cosine of this angle, is equal to our adjacent over our hypotenuse. Say that 5 times real fast. The ratio of this side over this side. That is our cosine. And we've got one more. we can say that the tangent of our designated angle, or the tangent of theta, is equal to our opposite over our hypotenuse. And those are the three trig functions we're going to use. We're going to use sine, cosine, and tangent. And there's an easy way to remember the ratios. Instead of having to have this hard memorization problem, we can just come up with this mnemonic, and it is this. I'm sure a lot of you guys know it. So, ka, toa. So, sine is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. And toa, tangent, is opposite over adjacent. Now, you should never forget that. I'm sure you actually already knew that coming into this. Now, as we did in the previous video, let's start throwing some numbers at this and playing with this and figuring out how we can determine angles. So let's use the common 3, 4, 5 triangle here. You can use Pythagoras theorem to determine that 3 squared plus 4 squared equals 5 squared. It all plays out from the last video. You can prove that. Now what we're trying to do is determine what this angle is, because that becomes very important to us in electrical theory later on. Now we can use any of those three trig functions, sine, cosine, or tangent. So what we're going to do is walk through with all three. Let's start out with sine. The sine of this angle is equal to our opposite over our hypotenuse. So sine theta is equal to 4 over 5. So let's just write that off on the side there. The sine of theta is equal to 4 over 5. Now let's get rid of that 4 over 5 and turn that into a number we can deal with. The sine of theta is equal to 4 divided by 5, which is 0.8. So now comes the tricky part. We've got sine of theta is equal to 0.8, but we don't want that sign there. We want to get rid of that. We want just to figure out what the theta is, or what the angle is. So what we're going to have to do is use our calculators. And if you take a look at your calculator, you should have trigonometry functions on your calculator. If you don't, then you've got the wrong calculator on you. And if you have a smartphone, you can probably just take your calculator out, and if you lay it on its side, it should pull up some trig functions. But let me show you a picture of the calculator that I use when I'm teaching this stuff. So what we need to do is find your inverse sine. Now if you look at this calculator here, I've got my trig functions up here, sine, cosine, and tangent. I've got sine right there. Now if you notice up above there, I've got sine to the -1. That's your inverse sine. Now I've got this second function. You see it's been worn out because I use it quite a lot. That's like your shift key. So you press second function, inverse sine, 0.8. Or depending on what your calculator is, it might be 0.8, second function, inverse sine. Every calculator is different, so you'll have to get used to it on your own. But that should get you the answer that you're looking for. That will get rid of the sine. So inverse sine 0.8 will give you the angle, which is 53.1 degrees. So there you go. We've solved the angle. We have solved theta using sine, which is our opposite over our hypotenuse. Now we're going to use the other functions as well. We're going to use cosine and we're going to use tangent, and hopefully this angle should work out the same using different ratios. So let's take a look. Using cosine of theta, same idea. All we have to do is take 3 divided by 5 because cos is adjacent over hypotenuse. So we take 3 divided by 5 and that equals 0.6. So the cos of theta is equal to 0.6. And again, using our calculator, we want to get rid of the cos. So we're going to inverse cos that. Let's take a look at that one. So just as we had before, we're just going to take the second function and we're going to use cos. So it'll be a second function, which gets you that inverse cos. So again, we'll point in 0.6, second function, inverse cos to get our answer, or perhaps depending on your calculator, it's inverse cos 0.6. Anyway you look at it, we're going to get an angle of 53.1 degrees. So we have determined using sine that we can get 53.1 degrees. We've now used cosine. That leaves us with tangent. Let's take a peek at that one. Using tangent, we use the formula TOA. Tangent of theta is equal to 4 over 3, opposite over adjacent. So the tangent of theta, let's turn that into a number, is going to equal 1.33. And again, we want to get rid of the tan, so we have to inverse tan that out of there. So let's take a look at our calculator one last time. So let's take our button here and press inverse tan 1.33 equals, which is that guy, or you're going to put 1.33 inverse tan, again depending totally on your calculator, and you should get your angle, which we're hoping is going to be 53.1 degrees, aren't we? Let's take a look. Well, what do you know? It is 53.1 degrees. So there you go. We have determined using any of these three sides, using either sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, or tangent, which is opposite over adjacent. Using those fun trig functions, we can use it to determine the angle. And that's what we're doing with this one. Now what we're going to do next video is determine what to do when you've got just an angle and a side. How do we work that out? Hopefully this was helpful. If you have any questions at all, please leave a comment in the comment section, and we'll see you in the next one. In this video, part 2 of trigonometry, we are going to determine how to figure out the sizes of the sides, these guys here, using nothing but a side and an angle. So in this example, we're going to have 35 degrees for a designated angle, and we're going to have 250 whatever for our hypotenuse, and we're going to try to determine what this adjacent side is. So if we have adjacent, we have hypotenuse, and we have an angle, we should be able to remember from our last video that we're going to use cosine because we have adjacent over hypotenuse, but we don't know what this is. So let's plug some numbers in. We'll work our way down the formula and see what happens. Let's remember that the cos of theta is equal to adjacent over hypotenuse. Let's start out with plugging the numbers that we know. So we know that the cos of theta is also the cos of 35 degrees is equal to the we don't know over 250. Let's transpose that now. However, before we transpose, let's just get rid of this cos 35. What we're going to do is just punch it in your calculator, and if you need to remember how to use the calculator, watch the last video. But instead of using our inverse cos, we're just going to go cos, hit the cos button, 35 degrees, and that gives us 0.819. 0.819 is equal to we don't know over 250. Now we can start the transposition. We flip it around, so we're going to divide this guy out of here. We're going to move this guy over to here. So we end up with the unknown is equal to 0.819 times 250, because all we have to do is cross multiply. And we're going to get an answer of 205. So that's not that bad. Let's get that written in there. So basically it is just like using what we did in the last video, except now we just need to know what this side is. So we're using the same formula. We just have our unknown over here as opposed to our unknown being the angle. So that's using cos. So we're going to walk through all three as we did in the last one. So that's cos. For our next one, we're going to use, well, looking at this here, we have an opposite and we have adjacent and an angle. So to me, it looks like we're going to use tangent. Tangent of theta is equal to opposite over adjacent. So let's plug the numbers in that we have. The tangent of 48 degrees is equal to 300 over what? We punch tan 48 in our calculator and we get 1.11 is equal to 300 over what? So we transpose that. Now we've got 1.11 times we don't know is equal to 300. So we'd have to make one more step in our transposition, which tells us that our unknown factor here, or the what, is equal to 300 divided by 1.11, and we get our value of 270. So let's get that plugged in there. So there you have it. Again, just using tangent with what we know. Now it leaves us with one more. We've already done cosine and we've already done tangent, so let's mix it up a bit, and we're going to finish strong with sine. Now you can tell we're going to use sine because we have an unknown here. We have our hypotenuse, so we have our opposite side, which is unknown. our hypotenuse, which is 750, and our angle, which is 67 degrees. So our sine is equal to opposite over hypotenuse, which is shown right here. Sine of theta is equal to opposite over hypotenuse. Let's plug in the numbers so we can see what we're working with. The sine of 67 degrees, which is theta here, is equal to, we don't know what that is, but we do know that the hypotenuse is 750. So let's get rid of the sine of 67, punch sine 67 into your calculator, and then you get 0.92 is equal to the unknown divided by 750, and we can just cross multiply. Let's take a look what's next. Using cross multiplication, we end up with our unknown is equal to 0.92 times 750, which gives us a numerical value of 690. So let's punch that into our side of triangle here. And there you have it, 690. So we've gone through them all. We've gone through tangent using a side and an angle. We've gone through cosine using a side and an angle. And now we've gone through sine using a side and an angle. It's not that hard once you have the concept of that sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Once you've got that down, if you go through these couple videos a couple times and some worksheets, you should have no problem at all. This video is going to be the first in a series of videos I'm going to do on adding vectors. Now, in order to properly add vectors, and the easiest way to add vectors I find is using the quadrant system. And what I mean by a quadrant system is this thing here. I've got this guy divided into 4 spots, hence the quadrant. Now I'm just going to go over some characteristics of the quadrant, and then the next video I'll start talking about converting from one form to another, and the next one will be another form to another, and then we'll get into the addition of the vectors. Now in our quadrant system, we have 4 quadrants. We have 1, 2, 3, 4, and they are labeled as such. Here I've got quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. Now we have them kind of backwards. They go in a counterclockwise direction, you'll see here. That's because vectors, when they rotate, and we'll talk about this later on, but they rotate in a counterclockwise direction. So I'm going to label them this way: 1, 2, 3, 4. Now when we're dealing with these quadrants, it's very important that we understand the angles that we're dealing with. Now I'm going to start right here and say that this point right here is angle 0, up here is angle 90. So in quadrant 1, we are dealing with angles between 0 and 90 degrees. Quadrant 2 is between 90 and 180. So again, quadrant 2 is going to deal with angles between 180 and 90, so 90 and 180. And then so on and so on. We've got 180 and 270, 270, and 360. So that's the angles. That's going to be very, very important as we move on in this. Now, as we're looking at the system here, it's very important that we understand how the polarities work in each quadrant. Now, just as a quick refresher for this quadrant system, we're going to talk about the x and the y-axis. X-axis is anything that runs this way horizontally. Y-axis is anything that runs vertically. We have a part here where they intersect. We're going to call that our point of origin. Now, anything that is to the right of the point of origin is going to be positive. Anything that is to the left of the point of origin is going to be negative. Anything that is above the point of origin is going to be positive. And anything that is below the point of origin is going to be negative. So when we're dealing with quadrant number 1, we can see that we are dealing with something that is in this quadrant here and this quadrant here. On my x-axis, it's positive. On my y-axis, it's positive. Therefore, x is positive and y is positive. This will make more sense as we throw some numbers at it in our next video. Now, if we look at quadrant number 2, we're dealing with a quadrant where the x is negative. It's on the left-hand side of the point of origin, but the y is still above the point of origin. So our x is negative and our y is positive. In quadrant number 3, my x is negative because we are to the left, and my y is below the point of origin, so x is negative, y is negative. And to sum things up to be talking about quadrant number 4, I see that I am to the right. So my x is positive, but I am still below the point of origin, so my y is negative. So that's how we work out the quadrant system. Again, we have 4 quadrants, 1, 2, 3, 4. This quadrant is anywhere between 0 and 90, 90 and 180, 180, 270, 270, 360. And then we have our polarities, positive, positive. This one here is negative, positive, negative, negative, positive, negative. And that's how the quadrant system works. In the next video, we'll discuss what happens when we throw some numbers at these things, and we're going to start converting from what's called polar to rectangular. In my last video, we discussed what the quadrant system was. Now I'm going to get down to brass tacks and show you why it's important. Now, the reason why we use quadrants is because of vectors. And a vector is something that contains magnitude, so how large it is, and direction, which way is it heading. A vector can show up in any of the 4 quadrants, 1, 2, 3, or 4. In this case, this vector here is whatever size this is at whatever angle, which is the direction, in quadrant 1. There's 2 ways that we can look at vectors. We can look at them in what's called polar form or rectangular form. In this video, I'm going to go through about converting from a polar vector to rectangular coordinates. So let's take a look here. Now in this example here, I'm saying that this vector is 20 volts and it's heading off at 35 degrees. The way that we've expressed this vector is in what is known as polar form. So it's giving you its magnitude and at what angle it's going at. So magnitude and direction. Now, when we want to add vectors, however, it would be a lot easier for us to kind of break these guys down into an x and a y coordinate. And we can do that now because you guys have been given the power of trigonometry. We know that this guy here is 20 volts, so that's my hypotenuse. If I want to figure out what my x is, I can figure out this guy here and this guy here. That makes us a right triangle. So I can use trigonometry. Now, if I want to figure out what the bottom is here, the adjacent to this angle, I'm going to use cos. When I want to figure out what my y is, I'm going to use sine because I've got cos is adjacent over hypotenuse and sine is opposite over hypotenuse. So let's kind of break this down here. Using cos, I can figure out what my x coordinates are. I can take 20 volts times the cos of 35 degrees, and I get that my x is going to work out to be 16.38 or 16.4 if you want to get funky with the rounding. Now I'm going to take the same thing, I'm going to go 20 times the sine of 35 degrees. It's just a little shortcut instead of having to transpose all the time. And I'm going to get my y coordinate. Actually, I've got that 16.4 there. Now my y is 20 times sine 35 is 11.47, which is going to be this side right here. So I've got that punched in there. So basically now I have my x and my y, which is the same thing as this here. So this form, 20 volts at 35 degrees, is your polar form. Your x being 16.4 and your y being 11.5, that is what's known as rectangular. And we differentiate our y from our x by throwing a little j in front of it. And you can go to my notes in my lesson plans that I'll have, and it'll explain, give you a little explanation as to why we use j. So there we go. We've got 16.4 or 16.38 and j 1147. That is the rectangular form. This guy and this guy, they are identical. So that's in quadrant 1. Now in quadrant 1, remember that it's both positive x and positive y. What happens when we end up in quadrant number 2? Boom, here we got 60 volts heading at 150 degrees. So we know that in quadrant 1 was between 0 and 90. Quadrant 2 is between 90 and 180. So that's going to throw this vector into quadrant number 2. Now the same thing's going to go here. All we have to do is go 60 times the cos of 150 is going to give me my x. And 60 times the sine of 150 is going to give me my y. 60 times the cos of 30 degrees gives me 51.96 for my x size. Now let's take a quick look at this before I go on. I've got negative 51.96. That's negative because I've got my point of origin here, and on the x it's negative. Remember from my last video. So that's very important. If you forget that, you're going to screw yourself over when it comes to adding vectors. Do not forget the polarity. Now if I take 60 times the sine of 30 degrees, I end up with my y being 30. Now it is above the x-axis, right? I'm still in this positive sense here. So I could say that this guy is going to be positive 30. So now I can say that my coordinates, my rectangular expression of this vector, is going to be negative 51.96 and j30. So that's giving us our second quadrant. Now, why don't we fool around? We've got 2 more quadrants to go through. Why don't we just do them and get them over with? And that way you guys can see how it works for every single quadrant. Now in quadrant number 3, I've got 100 volts, which is the size, the magnitude, and 200 degrees, which definitely throws me in the third quadrant because anything between 180 and 270 gives me quadrant number 3. Again, I'm going to go 100 times the cos of 200 degrees gives me my x, which is going to be negative, and in this case, my y is also going to be negative. So 100 times the cos of 20 gives me negative 93.97. See, I've got that negative in front of it. 100 times the sine of 20 gives me 34.2. But I put down negative 34.2 down there. And then I can express this as negative 93.97 and negative j or j negative 34.2. So again, this is polar, this is rectangular. And let's finish it up here in quadrant number 4. I got 90 volts at 320 degrees. So again, same thing. 90 times the cos of 320 degrees is going to give me a positive x. And then my y, however, is going to be negative. So again, I cannot stress enough the importance of those polarities. So 90 times the cos of 40 degrees gives me 68.94 right here. So that's going to be a positive 68.94. And next up, I've got to go 90 times the sine of 320 degrees, which would give me a negative number. Now I've got that as 57.85, which is right there. So that will be a negative 57.85. And there we have it. If I've got my polar form, which is 90 volts at 320 degrees, and these two guys here can be expressed as 68.94 negative j 57.85. And that's how you convert polar to rectangular. Polar is when you've got the magnitude and the direction. So you've got your angle and the size. And rectangular is your x and your y coordinates. And remember that our y is always preceded with a j, just so we can tell the difference between the two. And also, again, I know I keep saying it, but do not forget your polarity. In this video, we're going to be going over how to convert from rectangular form, which is when we break it down to an x and a y coordinate, when we take a vector and we work out what its x is and its y. We're going to take the rectangular form and convert it to polar. So what we're going to do here is we're going to start out with this vector right here. We've got an x of 25 and a j of 50, which means that we've got an x of 25 and a j of 50 here. It means we're going to be in quadrant number 1. So let's throw some numbers at that, throw a picture up here just so we get our head wrapped around it. So I've got 25 on my x and I've got 50 on my y. So let's just draw the vector in. So I've got 25 here and 50 here. So now what we need to do is figure out what our hypotenuse is going to be. And this is our resultant, which is the first part. This is the magnitude that we're looking for when we talk about the polar form, as we learned in our last video. So we're going to go 25 squared plus 50 squared gives me the square root of. We end up with a resultant of 60. So that is the magnitude. Now we need to figure out what direction it's heading in, and that would be our angle. So what I'm going to do is use cos. I'm going to go 25 divided by 60, and then I'm going to inverse cos that. And if you want to know why I'm doing that, you just need to watch the videos on trigonometry, but I'm taking my adjacent side and my hypotenuse, and adjacent over hypotenuse is the ratio of cosine. So I do that. The cos of 25 divided by 60, inverse cos that, I get 65 degrees. So now I've done it. I've figured out that my magnitude is 60. That's my resultant, the hypotenuse. The angle here is 65 degrees because I'm in quadrant 1, which is this quadrant here. Again, watch the video on quadrants. It's anywhere between 0 and 90 degrees. I can just easily say that it is 60 at 65 degrees. So there you go. We've got 60 at 65 degrees is the polar form of 25J50. That's in quadrant number 1. Let's move around the 4 quadrants like we've done in the previous videos, and let's see what happens. So in this example now, we've got negative 45, which is negative 45 is on my x, so it means it's heading this way. 60 means it's heading up, so that puts me in quadrant number 2. So let's get that started to be drawn up. So I've got negative 45 right here, and I've got 60 here. Again, through the power of Pythagoras, 45 squared plus 60 squared gives me the square root of 75. 75, again, is my resultant. Now what we're going to do is we're going to figure out what the angle is in here, and this part's really important. So let's take 45 divided by 75 and inverse cos that. And that gives me 53.1 degrees. So now I've got all the sides and the angle here. Now, if I was going with polar form, I could say 75, but I cannot say at 53.1 degrees because we need to look at which quadrant we are in. We are in quadrant number 2, which means that our angle has to be anywhere between 90 and 180 degrees. Well, we know that this guy here is 53.1 degrees, and we're looking at the angle as in reference to 0, so we want this angle. So what we're going to do is just take this guy here, 180, minus the 53.1 degrees here to get my actual angle in this quadrant. And I get 129.6 degrees. So now I can easily say that this guy here, this negative 45J160, has got a polar form of 75 at an angle of 126.9 degrees. And there you go. That 126.9 tells me we are in quadrant 2 as well. Let's move it around. Let's go on to quadrant 3. So now I have negative 120, negative J40. So negative 120, negative J40. We know for sure that we are in quadrant number 3. Let's start playing around with this. Get it drawn up here. 120, so that's the negative 120, puts me on this side of the x at the point of origin. 40 is down here, so now I need to figure out what my resultant is, or my hypotenuse, and that works out to be a hypotenuse of 126.5, which is my resultant. So again, we're getting there. Now we just need to figure out what this angle is. Again, using cos, I'll go 120 divided by 126.5 and inverse cos that guy, and I get an angle of 18.5 degrees. Now again, we are in the 3rd quadrant. I can't go ahead and say it's 126.5 at 18.5 degrees, because then you think I'm talking about the 1st quadrant. So before, in the last one, we went 180 minus that angle that we worked out to get the angle. Now we're going to go 180 plus the 18.5, and that will give me my angle, which is 198.5. So now we can say that our rectangular form, which is negative 120, negative J40, has got a polar form of 126.5 at an angle of 198.5 degrees. There we go. So we've done the 1st quadrant, we've done the 2nd quadrant, we've done the 3rd quadrant. Let's move on to the 4th quadrant. Positive 30. So we're moving this side of the point of origin, negative J75 going below there. Again, we are in quadrant number 4. So as we've done before in every single quadrant, all we have to do is draw that in there, get your triangle drawn in. 30, 75. Using Pythagoras, we figure out what my resultant is. 80.7. Now we're going to work out what our angle is here. 68.2 degrees. So now we can say that we've got a resultant of 80.7, and we know that this little angle in here is 68.2 degrees. Now we said that this angle on this side was 180 minus. The angle on this side is 180 plus. we could say that the angle over here is 360 minus, and that will give us an angle of 291.8 degrees. So we could say that this guy, 30 and negative j75 rectangular, is the same as saying 80.7 at 291.8 degrees. But what we can also say when we're dealing with the fourth quadrant is we can work our way backwards. Now, I won't go too much into why we can do this. You can do this with every quadrant, but we'll do this with the fourth quadrant because it's somewhere between 0 and 90 backwards. So it'd be 0 and negative 90 this way. We can look at it and say, okay, we got 80.7 at an angle of negative 68.2 degrees. It's the same thing as long as you work backwards. Now, we generally only do this in the fourth quadrant. So you can work out what this angle is and throw a negative in front of it using this resultant, and you can work out what that is. Now, it's very important that we understand how to do these conversions, because in our next video, we're going to start talking about how to add vectors. See you there. In this video, we're going to take everything that we learned from our previous videos on vectors, whether we're converting from polar to rectangular or rectangular to polar. We're going to be doing all in this addition of vectors. So in this video, I've got, let's move that right on back. In this video, I have three vectors. I've got one vector here, 20 volts. I've got this vector here at 35 volts, and I have this vector here at 100 volts. Now we need to look at these. We're going to use this 20 volts as our reference. So I'm going to say that this guy here is 20 volts at 0 degrees. I've got 35-degree angle in here, so this will be 35 volts at 35 degrees. And then beyond that, I have 100 degrees. So I'm going to add that 100 to the 35. So I'm going to say I've got 100 volts at 135 degrees. Now the first thing we want to do when adding any vectors is we want to put up our XY chart. So I've got myself an XY chart up here because it gives me a reference. Then I start figuring out what my rectangular version of these polar forms are. So I'm going to take 20. I've got 20 at 0. It is all x. So I've got 20x and 0 for the y. So we're going to get that plugged in here. Now for this guy here, I've got 35 volts at 35 degrees. So what I'm going to do with that is I'm going to take the cos of 35 degrees times 35 volts, and I get my x, and I'm going to take the sine of 35 degrees and multiply that by 35 volts to get my y. And that gives me 28.6 on my x and J20.1 on my y. And my last one here is just going to take the cos of 135 degrees times 100 volts will give me my x, and the sine of 135 degrees times 100 volts gives me my y. So plugging that into the calculator, I get my x being negative 70.7, and I get my y being 70.7 as well. Except it's negative 70.7 here, because we can see that if I drew this into a quadrant system, this vector here is in my second quadrant. So it'd be a negative x and a positive y. Now I go ahead and I add up all my x's and I add up all my y's, and I get my rectangular version of the addition of these vectors. So I get negative 22.1 for my x and J90.8 for my y. Now I've got a bunch of numbers here, so what I'm going to do, and I would suggest you do this if you're working on these, is draw up a separate quadrant just for this vector alone, because you're just going to end up getting yourself messed up if you start trying to add it to this bunch here. So we're going to do that right now. So here we go. I've got negative 22.1 here. That moves me into the second quadrant, and I've got J90.8 here. Then I'm going to work out what my resultant is. So what is this guy here? That will be the answer for my polar form. So my resultant is 93.5. And then next thing I've got to do is work out what my angle is in here. So we're just going to go negative 22, or just take 22.1 divided by 93.5, inverse cos that, and I get an answer of 76.3 degrees. Now again, we are in quadrant number 2, so my answer is not 93.5 at 76.3 degrees. I've got to take 180 degrees here and subtract 76.3 degrees from it. So 180 minus 76.3 gives me 103.7 degrees. So taking those three vectors and adding them together, I get a resultant, an overall resultant of 93.5 at an angle of 103.7 degrees. And there you go. So all you have to do is, if you didn't really follow through with this one, make sure you go back through the other videos, go over how to convert from polar to rectangular, rectangular to polar, the quadrant system. It all comes to a head in this one here, and we have ourselves vector addition. And it doesn't matter if I have one vector, two vectors, three vectors, I just keep putting the x and the y's in and then add them up all in the end.